All right, so POD 8.4, radical notation for nth roots. So we just got some practice problems here. Distribute and simplify. That's going to be 4 minus 2 root 3 plus 2 root 3 minus 3, right? Because root 3 times root 3 is 3. Then we can simplify. 4 minus 3 is 1. And negative 2 root 3 plus 2 root 3 is 0. So it's literally just going to be 1. We notice that these are conjugates, right? So the roots sort of undo each other. Give a counterexample to the statement, for all h, the fourth root of h to the fourth equals h. Well, what if h equals negative 1? Then the fourth root of negative 1 to the fourth is actually equal to the fourth root of 1, which is equal to 1. And 1 is not equal to negative 1. So that's a counterexample. So we could say that the fourth root of h to the fourth is equal to the absolute value of h. Or we could say that this is true if h is greater than or equal to 0, but not if h is less than 0. Multiple choice. When x is greater than or equal to 0, the ninth root of x to the fourth equals which of the following? Oh, this should be x to the 4 ninths. Yep, for sure. Ninth root to the fourth. Is number 3 still true if x is less than 0? Yeah, the answer is a yes, since it's an odd root, right? Because you can take an odd root of a negative number, and so this would be fine no matter whether you do the root or the power first. Okay, 5 says, frequency f of a note that is n notes above a note with frequency little f can be found by using this formula. Capital F equals little f times 2 to the n over 12. Write this formula using radical notation instead of a fractional exponent. Well, this would be f equals f times the 12th root of 2 to the n. So we're going to write that with a 12th root instead of 2 to the 1 over 12. Suppose you want to know the frequency f of a note 5 notes above a note with frequency f. Write a formula for f using radical notation. It would be capital F equals little f times 12th root of 2 to the 5th. Write the square root of the square root of the square root of 4 using rational exponents and simplify. Well, that's going to be a 4 to the 1/2 to the 1/2 to the 1/2, which is 4 to the 1/2 times 1/2 times 1/2, 4 to the 1/8. It says, is the expression an nth root of 2? Well, 4 to the 1/8 is 2 squared to the 1/8. And that's 2 to the 2/8, which is 2 to the 1/4. So yes, and I've justified it mathematically. That's the fourth root of 2. Evaluate without a calculator. Oh boy. All right. This is asking for the square root of the cube root of 64. Cube root of 64 is 4. Square root of that is 2. This is asking for the square root of the fourth root of 81 cubed. I don't know what 81 cubed is, but what I do know is that this is the square root of the fourth root of 81, and that cubed. So it might be easier to find the fourth root first, then cube it. It is, because the fourth root of 81 is 3, so I get the square root of 3 cubed. 3 cubed is 27, so that's the square root of 27. That is the square root of 9 times the square root of 3, which is 3 root 3, and that's as simple as I can go. Cube root of negative 27 is negative 3. Cube root of negative 1 is negative 1. Negative 3 plus negative 1 is negative 4. Square root of 16 is 4. Fourth root of 16 is 2. 4 plus 2 is 6. simplify completely. Square root of negative 3 squared. Negative 3 squared is 9. Square root of 9 is 3. That is proving that the square root of x squared is equal to absolute value of x. The fifth root of negative 3 to the fifth. That is still negative 3. The cube root of negative 64 is negative 4. The fourth root of 81 is 3. And 9 to the 3/2 is the square root of 9 cubed, which is 3 cubed, which is 27. Let k be greater than 0. Simplify this expression. Well, k to the 1/2 is the square root, so that's the square root of the square root of k divided by the square root of the square root of k, which is just 1. Discuss the difference and possible confusion between the square root of 9 and x squared equals 9. Well, square root of 9 is an expression, and it's just always 3. X squared equals 9 means that x, absolute value x, equals square root 9, so x could be 3 or x could be negative 3. So this is an expression that you simplify and you get one result, whereas this is an equation that you solve and you get 2. Okay, moving on to 8.5, 8.6. Cube root of 96. Identify the expression that is not equivalent to the given expression. 48 times 2 is 96, so that one's fine. Let's see here. Cube root of 12. This would be, 2 is the cube root of 8. So this is the same as the cubed root of 8 times the cubed root of 12. Is 12 times 8 96? I'm going to say yes, it is. That works. This definitely works. 16 times 6 is 60 plus 36. Yep, that works. 8 times the cube root of 12? No, that does not work. So that is the one. That's the answer, because we're trying to choose the one that's not equivalent. If it were the cube root of 8 times the cube root of 12, but not 8 times the cube root of 12. Oh, this one's interesting. 6 root of 128, 6 root y 12, 6 root y squared. That should work. 2 to the 6th. Yeah, I think that's 128. Oh no, maybe 2 to the 6th is 64, but then times 2 is 128. Then 6, 12, 14, that seems legit. 6 root of 128, 6 root of y to the 14th, that one's definitely true. 64, y to the 12th? No. This is no good, I don't think. We'll come back to that. 2 to the 7th, y to the 14th, that looks good. And 2y squared, yeah, because when you pull out y, you should have 2 left, because 14 is 12 plus 2. Yeah, so this is the one that does not work. If you're going to pull out the y to the 12th, it would be y to the 12th divided by 6, which would just be y squared, like it is over here. Distribute and simplify. These are conjugates again, so we should get 1 plus root 3 minus root 3 minus 3, which is simply negative 2, because these are gone. Rewrite 1 over root 2 with a rational denominator. We write 1 over root 2 times square root 2 over square root 2, which is simply square root 2 over 2. True or false? X is greater than or equal to 0. 6th root of x is equal to 12. The 12th root of x squared. This is true. Okay, that's x to the 1/6. Does it equal x to the 2/12 if x is greater than or equal to 0? Yes, because 2/12 simplifies to 1/6. 4th root of x times the cube root of x equals the 12th root of x squared. Well, the 4th root of x is x to the 1/4. Cube root of x is x to the 1/3. Does that equal x to the 2/12? No, this equals x to the 1/12, because you would add those. But what is 1/4 plus 1/3? Well, it's 3/12 plus 4/12, so it should be 7/12, I think, x to the 7/12. So no, this is false. This does not work out. 7th root of x. So this is x to the 1/7, and this is x to the 1/7 again, and is that equal to x to the 2/7? Yes, it is. You would add those, so this is true. Finally, 5th root, cubed root, is that the 15th root of x to the 8th? Oh man, I'm not sure. X to the 1/5. x to the 1/3, is that equal to x to the 8/15? I think so, because this is going to be x to the 3/15, and this is going to be x to the 5/15, and when you add them, you get x to the 8/15, so yes, this is true. Which, if any, of the above statements would hold true for x is less than 0? Well, this would not, because you can't take the root of a negative, so it wouldn't really hold true here. This one might, because you're sort of taking an odd root. This one would, because you're taking an odd root. All right, finishing this up. Square root 2 or square root 6, right, with a rational denominator. That would be, well, this is already square root 2 over square root 2 times square root 3, which is just 1 over root 3. Now I can multiply it by root 3 over root 3, and I get square root 3 over 3. What is the conjugate of 1 plus 1 root 2? It's 1 minus root 2. Use the conjugate to rewrite with a rational denominator, so I'll multiply by 1 minus root 2 and over 1 minus square root 2. And that should give me 1 minus square root 2 all over 1 minus square root 2 plus square root 2 minus 2, which is 1 minus square root 2 all over negative 1, which is the same as negative 1 plus square root 2. 9 says, the power of P generated by a windmill is directly proportional to the cube of the wind speed. So P equals kW cubed. Suppose a particular small windmill generates 1.6 kilowatts of power in an 8 mile per hour wind. So this is W, and this is P. How strong must the wind be to generate 1 kilowatt of power? Well, I'm going to plug these in to find K, so I'd get 1.6 equals K times 8 cubed. So K is going to be 1.6 divided by 8 cubed. How strong must the wind be to generate 1 kilowatt of power? That would be 1 equals K, which is 1.6 divided by 8 cubed times W cubed. Then I'd want to solve for W, so I'd multiply by reciprocal, and I'd get 8 cubed divided by 1.6 equals W cubed. Then I'd raise both sides to the 1/3 power. And I would get W equals 8 divided by the cubed root of 1.6, whatever that is. Find B is number 10. Cubed root 12 times cubed root B equals cubed root 72. Well, then I know that 12 times B needs to be 72, so B needs to be 6. Square root 600 equals square root E square root 6 equals F root 6. Well, that needs to be square root 100, so E equals 100 because 100 times 6 is 600. And then F needs to be the square root of 100, which is 10. So F needs to be 10. And finally, write the expression in radical form with a rational denominator, assume that the variables are positive. So this is going to be z to the 3/2 divided by w to the 1/2, which is z, let's see, the square root of z all cubed divided by the square root of w. If I multiply by root w over root w, I should get the square root of z cubed square root w divided by w. And that takes care of it.